Hello viewers and welcome to the lesson. I would like us to solve this question on loci. Let me read through the question. Our model is in the shape of a polygon with vertices A, B, C, D, and E, such that AB is equals to 4.4 centimeters, AE is equals to 10 centimeters. Then we have ED is equals to 5.2 centimeters and BC is equals to 7.9 centimeters. The bearing of B from A is 0.30 degrees and A is due east of E, while D is due north of E, and angle ADC is equals to 120. A, using a ruler and a pair of compasses only. 1. Construct the accurate plan of the model. 2. Measure DC. B. A foundation plate is to be placed closer to CD than CB, nearer to D than to E, and not more than 6 centimeters from A. 1. Construct the locus of point equidistance from CB and CD. 2. Construct the locus of point equidistance from E and D. Then 3. Construct the locus of point 6 centimeters from A. Part C. Shade and label as R the region within which the foundation plate could be placed in the garden. So that is the question. So I would like us to solve it part by part. And as you can see, as you read through the question, you'll see these some concepts on bearing. Now we shall begin by drawing a rough sketch. Then after drawing the rough sketch of this polygon, we shall now go and draw the accurate one, and then we proceed with the rest of the questions. So part A, let us sketch this polygon. There is a polygon ABCDE. So the measurements are given there. AB, AE is given, ED is given. So I'd like to start here. I think I'll start by drawing these. Line AE, this seems to be the longest, 10 centimeters. And you have a condition here that A is due east of E. A is due east of E. So I'll start by having that. So that is the line. We shall have AE. And since A is due east of E, so let me put A here. It should be due east, exactly the directly east. So that is the line, and this one will be 10 centimeters. Then we have, while D is due north of E, D is due north of E. So where do we have? We have it should be somewhere here. Due north is exactly north or directly north. So it should be there. Let's see there. It's due north, directly north. And if it is directly north, then this one should be 90 degrees. And how many centimeters are these? And let me just indicate D, and given the measurement here. So D is somewhere there. And then angle EDC is equals to 120 EDC. So EDC. So let me assume that C will, that is where we shall have C will be somewhere here. C, so that EDC, that is at this angle, want to be 120 degrees. And then we have, let me see whether I have another one. Then the bearing is this part. The bearing of B from A is 0.30. The bearing of B from A is 0.30. B from A. So from A here, you can draw a true north. You can construct a true north here. So that is the true north. So bearing, don't forget that bearing, we measure bearing from the north in a clockwise direction. Like that, just sketching. So 30 degrees, 0.30 degrees is measured from the north in a clockwise direction. So therefore, B should be, let's say, somewhere there. Now we have all the positions of A. So we have A, we have B, we have, so you can join these. can join our C to make this in a polygon. You can join that. And now the measurements, we can give the measurements. AB is 4.4. AB is 4.4 centimeters. Then you have AE is 10 centimeters. I don't know is indicated there. ED is 5.2. ED is 5.2. This is a 5.2 centimeters. Then BC is 7.9. BC 7.9 centimeters. And then we have let's see whether I have another one I've not indicated. DC, given DC, the length of DC. Okay, DC is not given. You're supposed to calculate that. I think I've done the sketch. Now it is from this sketch that now we shall be able to do an accurate drawing. And remember, we're supposed to use strictly a pair of compasses and a ruler only. So let us go straight now and do the accurate drawing. So we shall start by drawing AE. So I have a ruler here, a pair of compasses. So I'll extend these. So I'll begin by just draw. We have the straight line here. We have a straight line here. These all have AE. So I will mark there. And this one to be point E. Then need how many centimeters? These are 10 centimeters. I need 10 centimeters to do this. So 10 centimeters. So 10 centimeters. This is that is 10. So 10 is up to that point. So we'll need to extend this line. It is properly. So to extend that, so the point A will be there. So this is 10 centimeters. Now from there we will have to construct true north here and construct this 30 degrees at A. So 30 degrees at A. So I'll have to once again now my tools are able to construct a straight line that will be 90 degrees. Now one thing that you're supposed to ensure is when you're constructing the true north, this angle here should be 90 degrees. And you're supposed to confirm using a protractor whether it is 90. I'm just using my tools here, and when I draw my straight line, it exactly meets this the other line AE at 90 degrees. So that is the true north. So I need to construct, and remember we're supposed to use a pair of compasses and ruler only. So I need to construct, to get 30, I will need to construct 60, and then I bisect it 60 degrees, then you bisect it. So like to construct, I have to extend this line once again. I'll have to extend it. Extend it. So 60 degrees. This is how you construct 60 degrees. Like that. Then so when I construct 60 degrees, there's something that you will notice here. Once I join, today I'm able to my line here is able to join this one. Let me do it again. I can use a ruler for that matter. You just use a ruler here. So by constructing, this is something that you notice here. By constructing 60, because this one is 60 degrees, you'll be able to remain with 30 here. And that is what we need. By constructing 60 degrees on that side, you remain with 30, and now we have obtained 30 from the construction of 60 degrees. So after doing that, we need now to take the measurement. That one should be 4.4. You take the measurement 4.4. So 4.4 is there. So that is a 4.4. You mark. And this is where we shall have the point B. So B will be here. So this is a 4.4 centimeters. And after doing that, now let us go to the other part, that is E. We want to construct D, which is due north, directly north of E. D is directly north of E. Now to construct that, of course, we need to, from my tools here, I can construct that line directly, but it's good because to explain this, better you don't just draw that line, a straight line that is to the north, but to ensure that it's directly north, you can construct a perpendicular at E. So how do you construct perpendicular at E? By just mark an arc here. So I have to again extend these. To extend that again. So mark an arc there. You're constructing a perpendicular at point E. Mark another arc there. Then now you can adjust and change the radius. So from there you can mark another arc there. This is just to ensure that the point D will be directly north, that is perpendicular. Like that. So now you notice that when you join using a ruler. If we join now this point E to the point of intersection of those arcs, that will be 90 degrees. So now, after doing that, should be 5.2. D should be 5.2. Distance of 5.2 from E. 5.2. So let me take that distance. So 5.2. So 5.2 is there. Then you mark it. So therefore D should be here. D should be there. Now this is a 5.2 centimeters, and don't forget that this one should be directing, not that one should be 90 degrees. After doing that, we need now to construct a 120 at point D. 120 at point D. That angle should be EDC, should be 120. So how do you do that? We need to construct 60 on this side. This is from the sketch. Once we construct 60 on the other side, we're going to automatically obtain 120 on the opposite side, since the sum of angles on a straight line should be 180. So now we need to construct, let me pull this on this way. We need to construct now 60 degrees from that side. So this is how we're going to do it. Now that is quite easy. So we'll just take a pair of compasses and then standing here. This is how you construct 60 degrees on that side. So I'll have to extend this line again. I have to extend this line. And that means it's okay. So standing here, mark an arc there, then mark another one there, then standing here, stand there, and then cut that arc. So that is how we're going to construct an angle of 60. And then from there you can take the ruler and join this point. So now after doing that, you notice that you have this something, you have 60 degrees here, that is 60 constructed, and you've managed to have the required angle here, which is 120. Why this is 120. So we need to, there's something that you need to do here. The only thing now you're remaining to get is the position of C, and to get the position of C, it will be quite easy. There's only one measurement that we've not indicated, that from B to C, that one should be from B to C, that should be 7.9. We're given that. So let me pull this on this way. Now we're given that B to C, that one should be 7.9, as you can see. So we need to measure that. So to measure that, we should I'll just use my pair of compass. So standing at B with measurement of 7.9, that is standing at B with measurement of 7.9. I'll just go and mark and cut that line there. That is from D, that line that runs from D. So I'm having the measurement of 7.9. This is standing at B. Then you cut that line, that point. So as you can see, this will be 7.9. That would be 7.9. So therefore, C will be here. C will be here. So just take a ruler and join. Just take a ruler, join these. So let me take a ruler and join B to C. So join it like that. And that is how it's supposed to do it. So now we have the required polygon. All the vertices are given, A, E, D, C, and B. All of them are there, they're given. Now let's answer the questions now. The first question, now we've done the first one using a ruler and a pair of compasses only. Construct the accurate plan of the model. 2, measure DC, 1 mark. DC, 1 mark. So to measure DC, I just use this, just use a pair of compass here standing at D. So standing at D, and then extending this all the way to this point. So this one should give 6.8. That is a 6.8. So we've answered the first one. So the first question, this one is a 6.8 centimeters. So that is a 6.8. Then let's go to the other part. Now a foundation plaque is to be placed closer to CD than CB, nearer to D than to E, and not more than 6 centimeters from A. 1. Construct the locus of points equidistant from CB and CD. Construct the locus of points equidistant from CB and CD. CB, look at where we have CB, and So that is the locus of point equidistance from two given sides that are intersecting. So that locus is drawn by constructing the angle bisector between the two lines. So for this one, they construct the locus of point equidistance from CB and CD. That will be the angle bisector locus. The angle bisector locus. The angle, you just identify the angle between the two sides, CB and CD, and then bisect that angle. And that angle is there. The angle is DCB. DCB. So we need to quickly bisect that. So let me bisect that angle. So taking a pair of compasses, then standing at C, this is how you bisect that angle. Let me reduce this one a little bit. Then with any radius, so mark an arc there without changing or adjusting anything. Mark another arc there. Then after making those two arcs, now you can shift the pair of compasses, stand on this one arc that you've drawn here. Then you can extend this one a little bit. Then from there you can mark an arc there. Then standing at that arc, you cut this arc. So that is how you bisect that angle. Then take a ruler, and then so to extend this one. So that is the locus. The locus of point equidistance from lines CD and CB is that angle bisector. So we've done that. Now the other question is construct the locus of point equidistance from E and D. Construct the locus of point equidistance from E and D. Now which type of locus is this? This one is the locus of points. This one is the perpendicular bisector locus. The locus of point equidistance from two fixed points. So the two fixed points here are E and D. So to get the locus of point equidistance from these two fixed points, we just get the perpendicular bisector of the line ED. This one is the perpendicular bisector locus. So we should just get that line ED, and then we construct the perpendicular bisector of that. So that is the perpendicular bisector locus. So let me bring this one closer here. So you can see where we have line ED. So we need to construct the perpendicular bisector of that line ED. That is what will represent the locus of point equidistance from E and D. So standing at E, and making sure you open it, you open a pair of compass more than half of that line, like that. So you can mark an arc there, and then can extend another one down here. So with the same radius without changing it or adjusting, standard D, then cut this arc that is here, and then also cut this arc that is here. Then take the ruler and join. So that is the perpendicular bisector locus, loci, that is the locus of point equidistance from E and D. So we've done that. Now let's see the next question. The next question here is construct the locus of point 6 centimeters from A. 6 centimeters from A. 6 centimeters from A. So what are you going to do? You're going to stand at A. We're going to stand at A. We stand at A. Then with a radius of 6 centimeters, just taking it with my pair of compasses there, 6 centimeters. So that is 6 centimeters. You mark an arc with that. So I'll ensure that I start from this line, the 6 centimeters standing at A, then mark an arc like that up to the other line BC. So that one represents now the locus of point 6 centimeters from A. 6 centimeters from A. Stand at A with a pair of compasses, taking that measurement of 6 centimeters and construct that arc. Now, I think we are through with all the three. If you noticed, the three statements here that we have, that is construct the locus of point equidistance from CB and CD, that is part 1, then part 2, part 3. All of them are represented by these. Like the first one was the foundation is to be placed closer to CD than CB. That is why we constructed these locus of point equidistance from CB and CD. Then it should be nearer to D than to E. That is why we constructed the locus of point equidistance from E and D. Then not more than 6 centimeters from A. That is, these locus construct the locus of points 6 centimeters from A. So now we've done everything. The last part is shade and label as R the region within which the foundation plank could be placed in the garden. The region that satisfies these three conditions, that should be closer to CD than to CB. Actually, what you're supposed to look at is the locus that you've constructed. It should be closer. Let's look at the first one here. It should be closer to CD than to CB. That is, we constructed the angle bisector of that is the angle between CD and CB. Okay, and then the other condition, it should be equidistance from E and D. Look at the line that way. So this one will simply be the region bounded by the locus that we started with, that is the perpendicular bisector locus. This one, the region bounded by these locus, this perpendicular bisector locus of point equidistance from these two given sides, DC and CB. Then also bounded by this line. This is the locus of equidistance from two fixed points, that is E and D. And also it should not be more than, it should be this one. There the locus. The locus should be 6 centimeters from A. 6 centimeters from A. It should not be more than 6 centimeters from A. So that is the region that we need to mark. We shall therefore look at this. The area, the required region R would be the region bounded by the first loci, which is this. Remember this, the perpendicular, the angle bisector. This one, this is the first locus. Then the other one is this, the other locus. And then we have these. And remember, it should not be more than 6 centimeters. So it should not go beyond, that region should not go beyond this arc. Then it should be bounded by this line here. That is the locus of point equidistance from E and D. So look at this boundary, look at this line, look at the other locus here, and look at this. So you notice that the region that we require therefore will be this region that is here. This is the region. This would be the region. This one. Now, therefore, we can conclude that region R satisfies all the three conditions. The first condition, that it is to be placed, the plate is to be placed closer to CD than CB. You can see the perpendicular, the angle bisector of CD and CB. You can see that angle bisector locus. That one stands for that. Then the other one, it should be nearer to D than E. It should be nearer to D than E. Look at the shaded region. It is nearer to D than E. You can see from the shading. So that one, we've been guided by that line, the perpendicular bisector of line DE. And then the other condition is that it should not be more than 6 centimeters. That is why we've shaded just behind that arc. Anything beyond that arc will not satisfy. Yeah, and that is the region that we shade and label it as R. And that is how you're supposed to solve that question. Thank you.